Hi guys, today we're going to go over lesson 15 and 16. Okay, you guys do not have to do your bell work problems on your homework paper anymore. Only just do the homework problems that are assigned under the content section of each assignment. Also make sure that you check out the discussion board. You guys can ask questions there, and if you know the answer to someone else's question, you can answer it there as well. It doesn't just have to be me answering the questions. It can be you guys answering each other's questions. So for the bell work, we're going to review. It says for number 20, what is the mean and the median of 2, 4, 6, and 8? We know mean is just another word for average, and in order to find the average, we have to add them all together and divide by the number of numbers. So we're adding 2, 4, 6, and 8. Okay, we know 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, and then there's 4 numbers, so if we do 20 divided by 4, our mean, or our average, would be 5. Okay, and then to find the median is the middle number. So first thing we have to do is put them in order from least to greatest. So 2, 4, 6, 8, and then cancel out till we get to the middle. So cancel, cancel. Whenever there's two numbers left in the middle, all we have to do is add them together and divide by 2. So 4 plus 6 gives us 10. Divide that by 2, and our median should also be 5. Okay, 21 says, write the prime factorization of 400. Use exponents for repeated factors. So 400, we know we can do 40 times 10. Okay, 40 could be 8 and 5. 5 is a prime number. 8 is 4 and 2. 2 is a prime number. 4 is 2 and 2. Okay, 10 is 5 and 2. Okay, so looking at it, we have 1, 2, 3, 4 2. So that would be 2 to the 4th power. And then we have 1, 2, 2, 5. So that would be 5 squared, or 5 to the 2nd power. Okay, 22, what is the product of the sum of 10 and 5 and the difference of 10 and 5? Okay, we know that sum means that we have to add. So if we add 10 plus 5, our answer will be 15. We know difference means that we have to subtract. So we do 10 minus 5, our answer will be 5. And then we know that product means we have to multiply. So if we do 15 times 5, we should get 75. Okay, again, you don't have to do your bell work on your homework paper anymore, but when we get back to class, we'll just be doing it on whiteboards instead of on the paper. Next thing is the review. So again, this is just extra information. That way you know how to solve these problems. So the first one is number 12. It says 4z minus 2 equals 30. We have to use our inverse operations because we know that some number minus 2 equals 30. So to figure out what that some number is, we're going to add 2 to both sides of our equations. So those ones cancel out, so we're left with 4z equals 32. And then we have to think about what number times 4 equals 32. The opposite of multiplying is dividing, so we divide each side by 4. So that means z should be equal to 8. Okay, number 13 says 200 minus a equals 140. We know that in order to find the subtrahend, all we have to do is add the minuend, subtract the minuend and the difference. So if we do 200 minus 140, our answer should be 60. Okay, number 14, 50 equals 5m plus 10. So we know that some number plus 10 equals 50. So to find that number, we're going to subtract 10 from both sides. So we're left with 40 equals 5m because these cancel out. Okay, and then now we know that some number times 5 equals 40. Again, the opposite of multiplying is dividing, so we're going to divide each side by 5. So that means that our missing number is 8. Okay, last one is number 15. It says 7 equals x divided by 3. Again, this little bar means division, so the opposite of division would be multiplication. So we multiply each side by 3, so our answer should be 21. Okay, on to the lesson. Lesson 15, the objectives are to simplify square roots and numbers raised to a power, write the prime factorization using exponents, and then find the nth root of a number. Okay, whenever we're dealing with exponents, the big number is called the base, the small number is called the exponent. Okay, when we're dealing with exponents, this is when we're multiplying the number by itself that many times. So 5 squared does not mean 5 times 2. That is not what it means. 5 squared means 5 times 5. Okay, the exponent tells you how many times to multiply the number by itself. So if we had 5 to the fourth power, again, that would not be 5 times 4. That would be wrong. It would be 5 times 5 times 5 times 5, because the exponent tells us that we have to multiply 5 by itself 4 separate times. Okay, so for letter A, here's our example, 5 to the fourth power. So this means 5 times 5 times 5 times 5. Okay, we know 5 times 5 is 25. So we could just do 25 times 25. Okay, 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 0 for placeholder. 5 times 2 is 10. 2 times 2 is 4, plus 1 is 5. Add these together, and we should get 625. Okay, letter B, 10 to the fourth power. Again, it does not mean 10 times 4. That is wrong. 10 to the fourth power means 10 times 10 times 10 times 10. Okay, the tens are easy because all we have to do is count the amount of zeros. 1, 2, 3, 4. So this would just be 10,000 since there's 4 zeros. Okay, example 2 says write the prime factorization of 72 using exponents. Okay, so I'm going to use a factor tree. 72, we can multiply 8 times 9 to get 72. 8 is 4 times 2. 2 is a prime number. 4 is 2 times 2. And 9 is 3 times 3. Okay, so what we have to do is first, we always want to put our numbers in order from least to greatest. So we're going to start with the 2's. First thing we need to do is count the number of 2's. So we have 1, 2, 3. So that means 2 times 2 times 2, or we could just write it as 2 cubed, or 2 to the third power. And then we have to count the number of 3's, which we have 1, 2. So then we're multiplying this by 3 squared, because again, that exponent tells us how many times we're multiplying the number by itself. So that would be 2 cubed times 3 squared. Example 3 says the figure shows a square floor tile that is 1 foot on each side. Find the area covered by the tile in square inches using the formula area equals side length squared. So the first thing we need to do is write down our formula. Area equals side length squared. Okay, we know that our side length is 12 inches, so we can go ahead and plug that in for S. So this means that area equals 12 squared. Okay, again, 12 squared means 12 times 12, which we know is 144. And then since we're looking for area, we know our label is going to be inches squared. Okay, next example is number 4. It says express with exponents, and it's 2 times x times x times y times y times y times z. Okay, the first thing that we're going to want to do is write down our number. So we know we have a 2. We have x times x, which means x squared. So we can write 2 as our exponents. And then y times y times y, which we know is y cubed. And there's just one lonely z. We don't have to write the 1. So we would just write 2x squared, y cubed, z. Okay, so however many there are of each letter is what your exponent should be, because that's how many times you're multiplying it by itself. Next is the inverse of raising a number to a power is taking the square root. So we use a radical sign, which is this symbol right here. This is called a radical sign. Okay, and then we use that number to indicate we use that symbol to indicate the root of a number. So if we had something like this, we would just write this, we would call this the square root of 55. Okay, but if we had something like this with a little 3, we would call that the cube root. So if it doesn't have a number, it's called the square root. If it has a 3, it's called the cube root. Okay? The number underneath the radical sign is called the radicand. So in this example, our radicand would be 55, since that's the number inside. Okay, and then the small 3 right here, that's called the index of the root. So the index of this one would be 2, since we know we're taking the square root. Okay, example 5 says simplify the square root of 144. Okay, so what we have to think about is what number times itself equals 144. Think about that. Think about your math facts. What number times itself equals 144? And we know that our answer would be 12, since 12 times 12 equals 144. Okay, so that's for the square root. You're multiplying by the number by itself 2 times. Okay, for the cube root, we have the little 3. That means what number times itself 3 times equals 27. So we know that 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 8. 3 times 3 times 3 equals 27. So that means that the cube root of 27 would just be 3, since 3 times 3 times 3 equals 27. Again, the square root is when you're multiplying the number by itself 2 times. The cube root is when you're multiplying the number by itself 3 times. Okay, next one is example 6. The floor of a square room is covered with square foot floor tiles. If 100 tiles cover the floor, how long is each side of the room? Okay, so what we have to do is find the square root. Okay, so if we know that the area is equal to 100 feet squared, to find the side length, all we have to do is find the square root. Okay, so our side length, the square root of 100, we know is 10, since 10 times 10 equals 100. And we know that if we are taking the square root of something squared, it just cancels out, so our label would just be feet. Okay, so whenever we have something like this, like the square root of 3 squared, the square root symbol and the exponent cancel out, so that our answer would just be 3. And we can think about that because we know that 3 squared is 9, and we know that the square root of 9 is 3. So that's kind of a shortcut. If you see something like this, we know that answer is just going to be 100, since the square root and the exponent cancel out. Okay, also if we had something like this, if we had the cube root of 27 cubed, again, the cube root and the cube would just cancel out. Last one is example 7. It says, name the first 3 counting numbers that are perfect squares, then find their positive square roots. Okay, so our first perfect square, we are starting with our first counting number, which is 1. So if we do 1 times 1, we should get 1. So that's our first perfect square. Okay, and then if we do 2 times 2, we should get 4. That's our second perfect square. And then 3 times 3, we get 9. So that's our third perfect square. Okay, perfect squares, they have to, when you take the square root, it has to be a counting number. So if we had the number 8, if we take the square root, we know that is not a counting number, so that is not a perfect square. If we had 16, we could take the square root, which we know is 4. And since this is a counting number, that means that 16 is a perfect square. Okay, moving on to lesson 16, we're going to be able to identify rational numbers or irrational numbers and real numbers, and then approximate, compare, and order irrational numbers. As a review, a rational number, so rational numbers are numbers that can be written as a ratio of 2 integers. So remember, it has that word ratio in it. So if it can be written as a ratio of 2 integers, then it's called a rational number. So for example, 3 over 2 is a rational number, since 3 is an integer and 2 is an integer. Okay, negative 1 is a rational number because we can write it as negative 1 over 1, and both of these, negative 1 and positive 1, are integers. Okay, 4 over 3 is a rational number. 7 is a rational number. Negative 100 is a rational number. Okay, so again, rational numbers are just a ratio of 2 integers. And then opposite of that is what we call irrational numbers. So irrational numbers are numbers that cannot be written as a ratio of 2 integers. Okay, one example of an irrational number would be something such as pi. Since that number goes on forever and ever and ever, it never, since that number goes on forever and ever and ever, we know we can't write it as a ratio of 2 integers. So that would be considered an irrational number. Same thing for something like the square root of 3. Okay, if you were to type that into your calculator, it would just keep going on forever and ever and ever, which means that it will be an irrational number. Okay, any counting number that doesn't have a perfect square would be an example of an irrational number. So square root of 1 equals 1, that's rational. Square root of 2, we don't know unless we type it into a calculator, so that would be considered irrational number. Square root of 3, we also don't know, so that would be irrational. Square root of 4, we know is 2, so that would be rational. So the square root of any counting number that's not a perfect square is going to be considered an irrational number. Okay, example 1 says which number is irrational? So the square root of 0, so what number times itself equals 0? And that is just 0, so we know that's rational. Letter B, the square root of 4, what number times itself equals 4? We know that is 2, since 2 times 2 equals 4. Okay, letter C, what number times itself equals 8? So we know that the only numbers we can multiply to get 8 are 8 times 1 and 4 times 2. There's no number times itself that equals 8. So that means that C is an irrational number, Okay, and then we can always check letter D. What's the square root of 16? What number times itself equals 16? That would be 4. Okay, so we know that C is our answer since no number times itself equals 8. Okay, rational numbers and irrational numbers together form the set of real numbers. So the real numbers, that is all the rationals and the irrationals put together. Okay, example 2 says arrange these real numbers in order from least to greatest. Okay, we know the smallest number on our list is going to be 0, since we don't have any negatives, so we can go ahead and cross that out. Okay, now we're going to be looking for numbers in between 0 and 1, which we know that 5/9 is in between 0 and 1, since the numerator is less than the denominator. So next would be 5/9. Okay, there's no other numbers between 0 and 1, so our next number would be 1. Okay, now we're looking for numbers in between 0 and 2. Okay, the square root of 5, so we know that the square root of 4 is equal to 2. So that means that the square root of 5 has to be more than 2, since 5 is greater than 4. So in between 1 and 2, we only have the number 1.2, so we can go ahead and write that down. Okay, and then we know that 2 is going to be next because the square root of 5 is greater than 2, since the square root of 5 is greater than the square root of 4, and the square root of 4 is 2. So we know that the square root of 5 is going to go in between 2 and 3, so after 2 we would write the square root of 5. And then lastly, our largest number would be 3. Okay, so when you're comparing square roots, the easiest way is just to compare them to perfect squares. So I knew that the square root of 4 was equal to 2, and the square root of 5 is a little bit more than the square root of 4, so that means that the square root of 5 is a little bit more than 2, since those two are the same. Okay, example 3 says the area of the square is 2 centimeters squared. What is the length of each side? Okay, so if we remember from lesson 15, we had a square that had an area of 100 feet squared. When we were trying to find the side length, all we had to do was take the square root, and we figured out that the square root of 100 feet squared was just 10 feet. Okay, so we're going to do the same thing here as if we have an area of 2 centimeters squared. To find the side length, all we have to do is take the square root. So we take the square root of 2 centimeters squared, which we know that there's no number times itself that equals 2, so we would just leave it as the square root of 2 centimeters for the side length. Okay, if you want to use a calculator, you can type in the square root of 2, but on your homework, you need to leave it in the irrational form, or leave it in the square root form, because that is the most exact answer. Okay. Okay, practice set. The two that I want to go over are letter C and letter D. Okay, it says letter C. Letter C says which of these numbers is between 2 and 3 on the number line, and how do you know? Okay, so we know that 2 is equal to the square root of 4, and we know that 3 is equal to the square root of 9. So in order for the number to be in between 2 and 3, that means it has to be in between the square root of 4 and the square root of 9. We know that the square root of 2 is not in between there because 2 is less than 4. We know that 3 is not in there because 3 is less than 4. We know that 4 is not in there because 4 is equal to 4, so that would be 2. So we know it has to be D because D is in between the square root of 4 and the square root of 5. Okay, the last one I want to go through is letter D. It says arrange these numbers in order from least to greatest. Okay, first we need to figure out which two numbers the square root of 2 is going to be in between. So again, you want to compare that to perfect squares. So we know that the square root of 1 is 1, We know the square root of 4 is 2. So since this is in the middle, that means that the square root of 2 has to be in between 1 and 2. So when we're ordering our numbers, we know that the negative is going to be our smallest. So we can go ahead and write negative 0.6. Okay, after the negatives, what divides the negatives from the positives is 0. So that's going to be our next number. Okay, and then we're looking for any numbers in between 0 and 1. Okay, 3/4 we know as a decimal is 0.75. So the next smallest number would be 0.5. And then 3/4. Okay, we got rid of those two. Okay, and then we know it's going to be 1, and then our largest number will be the square root of 2, since we know that that number is in between 1 and 2. So this should be the order from least to greatest. Okay, if you guys have any other questions on your practice set, make sure you come to Zoom for the office hours, or make sure you shoot me an email. I hope you guys have a great day.